Okay, what I wanted to do today was a quick Weierstrass substitution, and I have an integral here that's going to help us with that. We've got the integral of 1 over sine x plus cos x dx. Okay, as you see, I'm already set up for the Weierstrass substitution. I have all my formulas over here to the right. Now, I'm not going to derive any of these in this video because I've done that in the past. If you don't know where these are coming from or if this looks foreign to you, I'll provide some links in the description. You can look at some other videos where this has been derived. So since we have all of our formulas, this is going to go pretty quick. The most unusual part of it is the starting point. We're making a substitution for tan x over t, even though we don't have a tangent in the problem, we don't have any half angles. But this usually works out pretty well, because then we get a lot of cancellations. You see that we've got like a 1 plus t squared and everything. So we'll just go ahead and do this substitution right away. So for our dx value, we have this. I'll just have 2 dt in the numerator, and then I'm going to bring this 1 plus t squared over in this area. And then for sine x, we're going to have 2t over 1 plus t squared, and then cosine x is going to be 1 minus t squared over 1 plus t squared. And then we can go ahead and use this 1 plus t squared to cancel with this one here and this one here. And so then let's just clean this up and see what we have. I'll take the 2 out front of the integral. We'll have just this dt in the numerator. Putting this together, I think what I want to do to reorganize this is let's factor out a minus sign. So we'll factor a minus sign in front and then reverse the sign and everything. So this is going to become t squared minus 2t minus 1. And then what I want to do on this is let's actually complete the square. So then taking half of this coefficient here, we can write this as t minus 1 all squared. When you multiply that out, you get t minus 2t plus 1. We have a minus 1 here, so to make it the same, I can subtract off 2. So then we'll just rewrite it this way. We're going to have the minus 2 in front, and then this is just going to become this thing, t minus 1 squared minus 2. But for this minus 2, let's actually rewrite this to set this up to integrate. I'm going to write this as minus square root of 2 all squared. But now from here, in order to integrate this, I just want to use this formula right here. We could do this, you could actually express this in terms of natural log, but I'm going to actually do it. This formula is a little cleaner if we express it in terms of the inverse tangent. So like matching up with this formula, our x value is just going to be this t minus 1 here. You could do another substitution, but it's not really necessary because the derivative of this is just going to be dt. And then over here, our a value is just going to be the square root of 2. So now going ahead with this, we'll pull this minus 2 in front, minus 1 over the a value, square root of 2. Then we're going to have this tangent inverse. The x value is going to be t minus 1 all over the a value, square root of 2. Over here, minus times minus is plus. Now here, if you just rationalize the denominator by multiplying by square root of 2 over square root of 2, this whole thing is going to reduce to just the square root of 2. But now here, all we need to do is back substitute in order to finish it off. But I was kind of dumb and I erased all my formulas. So we need this t value back. But if you remember, t was just tan of x over 2 in our original substitution. So we can plug that in right here. So putting it all together for my final solution, we have just square root of 2, inverse tangent, then tan x over 2 minus 1 over square root of 2, add a plus c, and that's it. Okay, there you have it. Just a quick Weierstrass substitution. Thanks everyone for watching. Have a good day.